With the rising energy prices, people are seeking ways to make their buildings more energy efficient, and therefore we're going to explore two increasingly popular concepts, passive solar and passive house. You might have heard these terms thrown around in discussions about green and sustainable buildings, but what are these exactly? And more importantly, which of those two concepts is better? And should you use any of those principles in your projects? My name is Anton Dobrovsky, I'm a passive house trainer and I've taught hundreds of professionals how to design energy efficient buildings. So let's first start with passive solar. This concept is all about using the sun's energy and thoughtful architectural design to maintain a comfortable temperature and passively heat our buildings. No fancy gadgets, no high-tech wizardry, just good old Mother Nature and some smart design choices. After all, it's called passive solar for a reason, right? And even though the term is quite modern, the concept itself has its roots in ancient civilizations. The ancient Greeks were known to orient their buildings based on the sun's movement to take advantage of its warmth during the colder months. Aeschylus even wrote, "Only primitives and barbarians lack knowledge of houses turned to face the winter sun." And ancient Greeks weren't the only ones. The Romans too used similar principles to capture and store solar heat. They used it not only to heat their homes, but also their public baths and even their greenhouses. And if you're wondering, why aren't we all living in sun-warmed houses? Well, that's a good question, and for a long time the principles of passive solar design were largely forgotten, especially during the Industrial Revolution, as fossil fuels became the primary source of energy. However, it wasn't until the Second World War and the Great Depression in the US when there was more interest in cost-effective and efficient housing solutions, and in this time, architects started experimenting again and utilizing the sunlight to the maximum. And then came the energy crisis of the 1970s. This was a time when oil prices were skyrocketing and the world was beginning to realize that fossil fuels weren't going to last forever, which made the search for energy efficient solutions a top priority, and passive solar design found its way back into the spotlight. And that's when scientists, architects and engineers began looking for ways to heat and cool buildings more efficiently. And actually that's also the time when the term passive solar was defined as such. And architects started making projects with huge glass facades, but also experimenting with new technologies like double glazing and triple glazing, which allowed them to make houses with bigger windows and have more passive solar heat gains, but at the same time not to lose too much energy. But what were the principles used to design these buildings? At its heart, passive solar design is a three-step process: collection, storage, and control. Collection refers to harnessing the sun's energy. The solar homes used a narrow, stretched-out plan that allowed most living spaces to face the south, providing maximum exposure to the sun. And the south facade was mostly made out of glass to allow the sun's rays and provide a lot of natural light and heat to all the rooms. But what happens with the solar heat after it enters the building? Well, we have to store it so we can use it later when there is no sun and no passive heating from the outside. This is achieved using what we call thermal mass. These can be heavy materials like concrete, brick or stone, and you can think of them as a temperature battery. So they absorb the sun's heat during the day and slowly release it back into the house as temperature drops in the evening. And what about the summer? Well, to keep the buildings cool, these large south-facing windows are shaded by overhangs or shades to control the amount of direct sunlight during the seasons. In summer, they block out the high summer sun and protect the building from overheating, but still allow to maximize the heat gains in winter when the sun is lower. And Socrates observed this a long time ago, when he wrote, "In houses with a south aspect, the sun's rays penetrate into the porticos in winter, but in the summer the path of the sun is right over our heads and above the roof, so that there is shade." And we're still using these principles to design buildings nowadays. However, passive solar buildings had a problem, because this concept didn't always work. After sunset, these houses cooled down quickly. On cloudy days, when there were much less solar gains, these houses couldn't be heated properly, so they required additional heating, so there was still room for improvement. However, in 1988, two researchers, Wolfgang Feist and Bo Adamson, addressed this issue and took this concept a step further. They wanted to make a house without heating. But they didn't only focus on maximizing the passive heat gains. but also minimizing the energy losses while ensuring ideal comfort inside the building, irrespective of the external conditions. So they developed a comprehensive set of design principles, and in 1990, based on their findings, the first passive house project was built in Germany, under the supervision of Wolfgang Feist, who later founded the Passive House Institute. So the passive house concept was a big leap forward in the realm of energy efficient construction, and its effectiveness was proven with this first passive house project and has since then set the standard for sustainable construction worldwide, because this building uses 90% less energy for heating compared to standard buildings. And unlike passive solar buildings, a passive house isn't dependent on the sun's position or the outside temperature to maintain the comfort inside the house. Instead, it uses a well-insulated and airtight building envelope that ensures comfortable interior temperatures throughout the whole year. And passive houses also have high-performance windows, which maximize the solar heat gains just like passive solar buildings do, but are also designed to minimize the heat losses and keep as much heat inside the building. However, what truly sets passive house apart is the integration of an innovative ventilation system. So this system not only ensures fresh filtered air inside 24/7, but also recovers the heat from the air going out of the building that would otherwise be lost. So by combining these principles, Feist and Adamson created a home that can be heated primarily by passive heat sources such as sunlight, electrical appliances, and even the body heat from the occupants. In this home, ideal thermal comfort can be achieved solely by post-heating or post-cooling of the fresh airflow, which is required for good indoor air quality. And something else is that the passive house standard has clearly outlined performance-based requirements that a building has to meet, like how much energy the building uses for heating, cooling, etc. And these requirements are climate independent, meaning that passive houses can be built anywhere around the world. But they're also applicable to any type of building. I know it can be a bit confusing, but we have houses, office buildings, schools, even skyscrapers built to the passive house standard, and even existing buildings can be renovated to become passive house. And the good thing is that the passive house concept doesn't even define the technique with which this functional objective should be achieved. And that's why it's a performance-based standard and not a prescription-based one. So in the end, which one is better, passive solar or passive house? Well, it's difficult to compare apples with pears because passive house is like the next generation, an upgrade of passive solar. Because passive solar focuses primarily on harnessing the sun's energy, while passive house focuses on lowering the energy we need for heating and cooling by using passive strategies to maximize the heat gains like passive solar gains, but at the same time to lower the heat losses and ultimately find the ideal balance between losses and gains to achieve low energy demand and ideal comfort at the lowest possible cost. But I must mention here that if it wasn't for the passive solar concept, we might have not had the passive house standard. And I'm convinced that the passive house standard is here to stay as we move forward to the future, and it's likely that the passive house principles will continue to play a critical role in sustainable architecture, because the passive house standard is the first and only building standard in the world that combines the personal interests and desires of the individual with the public need for environmental protection. And if you want to learn more about the passive house and energy efficient buildings, make sure to check out this video. Thanks for watching, I hope you enjoyed it, and see ya next time.